Today we're taking you inside the world's first 18-story mass timber high-rise residential building. You may have heard of this before. It's called Brock Commons, and it's located on the campus of the University of British Columbia in Vancouver, Canada. We'll show you what went into the design and construction of this unique project, and we'll see how it's changing the future of high-rise construction around the world. This is part 1 in a 3-part series. There, actually a central core that runs the height of the building, and this core contains the stairs and the elevators. First, it sets a new standard for tall wood buildings. It shows us that we can build taller, greener, and more efficiently if we embrace new technologies and rethink how we build. In the next part of this series, we'll go even deeper into the details of how Brock Commons became the world's tallest mass timber building. We'll explore topics like fire resistance, seismic analysis, and how this building changed the course of green building. So make sure to subscribe and join us next time. If you've enjoyed this video, please leave us a comment below. Tell us what you found most fascinating about Brock Commons and what you'd like to learn in the next part of this series. Your feedback is important to us, and we can't wait to hear your thoughts. Don't forget to like and share this video if you think others will find it useful. We look forward to seeing you in the next part of our series. Till then, keep building and keep innovating. Before Brock Commons, the world's tallest mass timber building was 6 stories. Brock Commons rose to 18, pushing the boundaries of what was thought to be possible with wood. Second, it showcases the sustainability benefits of mass timber. As we mentioned earlier, CLT and Glulam are made of solid wood, which means they store carbon during construction. This contrasts with traditional high-rise materials like steel and concrete, which have a higher embodied carbon footprint. Using mass timber helps us reduce our impact on the planet and create a healthier environment. Third, it improves our urban environment. Mass timber has a lower embodied carbon footprint than steel and concrete, which means that we can create taller, denser buildings with a smaller environmental impact. Finally, it promotes the use of renewable resources. Unlike concrete and steel, which are non-renewable resources, mass timber uses wood, which is renewable. When we choose wood for construction, we're supporting sustainable forestry practices and ensuring that our forests continue to grow. This core is made of reinforced concrete. This concrete core stabilizes the structure and provides the necessary rigidity. The rest of the building is made of mass timber. The floors, the structural columns, and the non-load-bearing walls are all made of CLT or Glulam. This hybrid approach allowed the team to maximize the advantages of both materials and achieve the ambitious goals of the project. Let's dive into the materials that make this possible. First, CLT or cross-laminated timber. Think of this as the building block of Brock Commons. It's made of layers of lumber stacked on top of each other and glued together at right angles to form large panels. These panels are super strong, stable, and resistant to shrinkage and warping. They're also tested to exact specifications, so their properties can be precisely predicted. Then there's Glulam. That's the Glulam beam. It's made of layers of lumber glued together along the grain to form larger beams. Glulam is excellent for long spans and heavy loads, and it's used for things like roof trusses and bridges. Together, CLT and Glulam create a lightweight yet incredibly strong structure. They're also visually appealing and versatile, allowing for creative design solutions and unique architectural finishes. Part 1. Can wood really build tall buildings? I'm Erin Walker, a structural engineer who specializes in mass timber. And let me answer the question right away. Yes, wood can absolutely build tall buildings. What you need to know is that wood products have come a really long way from the 2x4 framing that you see in houses, and this is why. Today, we're going to use the most technically advanced wood products on the market called cross-laminated timber or CLT and glued laminated timber or Glulam. These are engineered wood products that are so strong and so predictable that instead of just being used for finishes or for framing, these materials become the main structure. Now that might sound impossible. But stay tuned because at the end of this video I'll show you how Brock Commons came together. In fact, what makes this building special is that its designers and builders took the idea of using CLT and Glulam to the extreme. Part 2. The 66-day assembly marvel. At 18 stories tall and 53 meters high, Brock Commons is one of the world's first tall wood buildings. That means it pushed the boundaries of what was possible with mass timber. So how did they do it? Well, here's where it gets interesting, because the entire mass timber structure was built in just 66 working days. That's 2 full floors every week. Let's take a minute to let that sink in. 2 floors per week. That includes the installation of CLT floor systems, Glulam columns, beams, and bracing. It also includes the installation of windows, exterior cladding, balconies, and other components. The pace was unprecedented. Installation of the CLT floor panels was fully coordinated, so that they arrived on site at the right place and at the right time. Each CLT panel was numbered to indicate its location. That's right, every single one. Crane lifts were choreographed in advance with software. This included load calculations, crane positions, and sequences. All of the bolted connections were pre-designed, which allowed for faster installation once the panels arrived on site. The coordination and planning that went into this is simply remarkable. The result was not only rapid construction, but quieter work, cleaner air, and fewer workers on site compared to a traditional high-rise building. The building itself hummed along quietly as each floor was lifted into place. All of this was accomplished with fewer trade contractors and with less disruption to the surrounding community. To put it simply, the team was able to install 2 floors every week because of extensive prefabrication, coordination, and planning that happened off-site. But there's a lot more to the story, because although this building is primarily made of timber, it's not 100%. Let's talk about some of the reasons why Brock Commons is important. So let's wrap up with the main takeaway. Brock Commons Tallwood House isn't just a tall building. It's a beacon for the future of construction.